Hi there, it's Mr. Harriet here. Welcome to this video which is on the surface area of cylinders. This is on the P1 outcome, so the first of our problem solving outcomes. And by this point you should have finished the fluency and the reasoning. If that's not done, please make sure you finish that before carrying on with P1. This video is going to be in 4 parts. So the first is a quick learning check. That's just a fluency question to make sure we're really ready for the problem solving. Then there's 3 examples for you. I've chosen these to try and cover some of the skills you need in this problem solving outcome. But this is quite a broad outcome. There are a lot of different skills in here. It is generally the kind of that problem solving outcome which requires some resilience and you to use some of your collecting skills, your organising skills to really make sure you're successful. So first things first, have a go at this question, please. So pause the video now and have a go. Okay, so you should have got either 32 pi meters squared, or if you've written that out in full form, that's 100.5 meters squared. That's to 1 decimal place. If you haven't got that, you need to go back and revisit the Hegarty task, which for this topic is 586 is your Hegarty task. So go back and try this one, please, to make sure that you're ready for this outcome. Now, I'm going to go through the first example now. Now, this example, which is on the screen now, if you want to have a go, pause it and have a go, feel free. But this example talks about finding the surface area of a semicircular prism. Okay, that's half of a cylinder, like it's drawn here. Now, our first instinct might be, right, I've got an equation that can find me the surface area of a cylinder. I'll just do that and divide it by 2. Now, I don't think that's the best way of approaching this question, especially because we want to build up the skills needed for problem solving. So the way I'm going to have a go at this one, and the way I'd like to see you try as well, is by taking each face one by one and making sure that we're using every single face when we're finding the surface area. So the first face I'm going to look at is this semicircular face on the front here, and I'm just going to label that A, so I've got a way of referring to it. Okay, and if I look at the semicircle A, okay, I'm just going to draw a quick sketch of it. Looks something like that. It really doesn't need to be an accurate sketch. Now, I know I've got one on the front here and one on the back, so I know I've got 2 of these. Okay. Now, I also need to identify and collect from my kind of main diagram any information that's relevant to me finding the area of this shape. Now, for that, it's going to be this dimension here. So I know that my radius is 4. Okay, my radius is 4. Now, I also need to, at this point, I've got 2 options. I can either just go ahead and start working out the area of this semicircle and then multiplying that by 2, but we can be a little bit more clever about this. What we can say, well, we've got 1 semicircle on the front and 1 on the back. Together, 2 semicircles will give me 1 circle, and that will have a radius of 4. So I know then that the area of that shape will be, of those 2 faces, sorry, will be pi times r, which is 4 squared. Okay, and I can write that nice and simply as 16 pi. Now, obviously, that has a value. I can type it into a calculator, but I'm going to leave it like that for the moment while I'm doing my calculations. Now, the second face I'm going to look at is this curved face on top. Okay, now I'm going to label that B, so I have a way of referring to it again, and I'm going to write B here. Now, we've seen this before on the Hegarty video, and hopefully you're comfortable with this by now, but we should be able to recognise straight away that shape, although curved, when we flatten it out in a net, would give us a rectangle. And our challenge here is to identify my dimensions. I can see that this height of the rectangle is 10. And now I need to think about what my base of this rectangle will be, because I know that the area of a rectangle is base multiplied by height. Now, the base of this rectangle, because on a full cylinder, this rectangle goes all the way around, and that's the circumference, this length, as we've seen. As this is half a cylinder, this length will be half of the circumference. Okay. Now, this bit can be a little bit trickier to kind of really see what I'm doing, but I know the full circumference, this is assuming it was a full cylinder, would be 2 pi r. But I know that this is actually half of this figure, and so I can get rid of that 2 and leave it as pi times r. Okay, now that's the base, so pi r, and I've then got pi r times by 10, okay, and I know that in this case r is 4, which gives me pi times 4 times 10, which is 40 pi. Now, my last face, the last one I'm going to look at, is on the bottom. Now, this one is easily forgotten, but there is on the bottom of this, the face that's touching the table, will also, and I'm going to label that as C, I'm going to do an arrow for it, will also be a rectangle. Now again, this is a sketch, it's just for outworking, it doesn't need to be perfect, but I can tell I'm going to have a height along here of 10, okay, and I'm also going to have this length here. Now this can be a little bit difficult, we're going to have to work it out, but you should hopefully be able to see that this is the diameter of my semicircle, which is twice my radius, so this becomes 8. So that means that the area of this is 8 times 10, which is 80. At this point, I need to think about how I find the total surface area. And again, this should be, hopefully at this point, relatively obvious to us. I'm going to just add together each of my surfaces. Okay? 16 pi plus 40 pi plus 80. And when I type that into a calculator, the answer that I will get is 255.9, and I need to just return to my diagram to make sure that I'm getting my my units correct. Now we can see that each of the units here is meters, so this will be meters and squared as it's an area. Importantly, this has to be squared. Now, my second example is on the screen now for you. If you would like to have a go at that, by all means do so now. Now, this question is similar and builds upon what we did in the previous question. We have a box which is a cuboid and a semicircular prism. Again, I'm going to treat it face by face. Okay, I'm going to start with my semicircular prism again. I've got A here. Now, A is a semicircle. I need to be able to identify how many of these I have. I've got one on the front, one on the back, so it's 2 of them. Again, I need to identify the important dimension. Now for this one, I want to find the radius of my semicircle. Now to do that, I can use this length here. And this length is the same as this length on the base. So I know that my diameter is 6 and my radius is 3. That means that the area of A, and again I've got 2 of them so I can treat this as a full circle, will be pi times the radius, which is 3 squared, which gives me 9 pi. That's 3 squared is 9 multiplied by pi. I'm then again going to look at my curved surface, and again this should be nice and simple for us because I know it will be a rectangle. I know that my height here is the same as this length, and so it will be 10. I then want to find this, which will be half of the total circumference if this was a full circle, and that is 2 pi r, but I know I'm dividing it by 2, so it just becomes pi times by r, and that's times by 10. Okay, so this length is pi r. Now I know the radius, I've said it's 3, so this is pi times r, which is 3. Pi times 3 times 10 is 30 pi. Now, those are 2 faces I've done, or sorry, 3 faces, because there's 1, 2, and the curved face. Now I want to look at my cuboid on the bottom. I've got this face on the front, I'm going to label as C. I can clearly see this is a rectangle. I have a base of 6. I have a height, which is the same as this height over here, of 8. Okay, and these I also have two of, importantly. Okay, I have two of these. I've got the front and the back. Now, I've got 6 times 8, which is 48. I also then have to multiply that by 2, which will be, sorry, I'll write that out. So 8 times 6 times by 2, which is 48 multiplied by 2, so 96. I'm then going to look at this side, which is D. The side D is also a rectangle. I've got a base of 10 along here. I've got a height of 8. That will give me 80. I'm then also multiplying it by 2 because there's two sides. I have 80 times by 2, which gives me 160. So that's 8 times 10 times 2, which is 160. I then have one last side I need to make sure that I'm using. Okay, one last side. And that is underneath. I'll label it E and draw a quick sketch. I have a length of 10, a length of 6, and this time I only have one of them. Okay, I only have one of them. So that will give me 6 times 10, which is 60. And this point again, I need to be able to find the total surface area. For that, I need to add together each of these, including that top one, and that will give me, when I do 9 pi plus 30 pi plus 96 plus 160, that will give me 438.5. Okay, and again I'm going to check for my units. Meters, meters, meters. Meters squared is my final answer there. Now, we have one more example to have a go at, and I'm going to put that on the screen now. Again, feel free to pause this and have a go if you'd like. Okay, so this is a slightly different form of question. We're given an unknown value for the height of this cylinder. So we've got a cylinder shown has a surface area of 320 millimeters squared. We want to find the value of x. So now, instead of just ploughing straight on and just going straight for a formula, we want to make sure that we can always build that formula ourselves. Remembering a formula on its own is relatively difficult. We need to make sure we can build it ourselves if we need to. Let's remember where it comes from. I know that when I'm working out the surface area of a cylinder, I have a circle on the top and a circle on the bottom. So there's two of those. So 2 times the area of a circle. I then need to add to that this rectangle where I have a height of h, and this is the circumference, which I know is 2 pi r. Okay. That means that when I'm having or working with the surface area of a cylinder, I know that the surface area is 2 times by the area of a circle, which I know is pi times r squared, and then I need to add to that 2 pi r and h. Now this is my formula I'm going to be working with. Now I know we know that, we've seen where it comes from, but it's really important we can always remember it. So going back to where it comes from, which is the actual faces of the shape, you've got 2 circles and 1 rectangle, and it creates this, will always help you. Now at this point we want to take the information, collect the information from this problem, and substitute it into our formula. So we're told the surface area is 320 millimeters. Okay, I'm told it's 320 pi, sorry, millimeters. So I'm going to write 320 pi here. I know that will equal 2 times by pi times by the radius squared. Now the radius here is 8 millimeters. So I'm going to write 2 times by pi, and then I've got 8 squared, okay, and I'll underline that so you can see where that comes from. And then I'm adding to that 2 pi, here's our 8 again for the radius, and then I'm multiplying that by our x, which is here, okay, so x, which is the height. Now, this looks very complicated at the moment, but we've got some information, we've got some stuff we can work out now. So that's our next step. I'm not going to do any rearranging, I'm not going to try and solve it straight away. All I'm going to do is just clean this up, because it's too messy for me to work with. So I've still got 320 pi on the left hand side. I know that that will still equal 2 times by pi times by 8 squared. Now, this can leave us 2 times by pi. I'm going to write 8 squared. I'm going to actually square 8, so that means I'm multiplying this by 64. Okay. I'm then adding, I've got 2 pi and x. What I'm going to do is go 2 and multiply it by this 8, and I will get 16 pi multiplied by x. All I've done is square the 8 and then multiply the 2 and the 8. Now, one thing to notice at this point, and another way we can make this easier for ourselves, is I want you to notice that I've got pi in every term of my expression, or my equation here. So what I can do to both sides, if I divide both sides by pi, what I will do is remove pi entirely from this equation. 320 will equal 2 times by 64. Now, I know that that's 128 plus 16x. Now, straight away, now I've done the 2 times the 64 to get the 128, but straight away this is a much simpler equation that you can definitely solve. I will then take away 128 from both sides, and I will be left with 192 on this side. And that will be equal to 16x. To finish off this question, I need to divide both sides by 16. And I will get x is equal to 12. As always, I need to check my units. This is in millimeters squared. This is in millimeters. So this will be 12 millimeters. Oh, and that is my final answer. Now have a go at P1 now for me, please. That should help you to access all of the questions. The very last question you will have to have a go at before asking too many questions. It looks very, very complicated and it's there to challenge you. But what you should do, please, is have a go, substitute your information, and I think you will then see how to proceed. Good luck.